Scatterplot and regression. So although this is not a statistics class, some of the topics in here that we cover are going to be statistics related. If you take a proper or formal statistics class, either here at the high school or when you get in college, then you'll do or go much further in depth than some of the things that we'll do in here. However, the things that we will do in here can help you out in a statistics class, and they can help you hopefully better understand the relationship between quantitative variables. And I know that sounds very mathematical when I say it, however, it's an incredibly useful tool in everyday life. So, here's our example. Fast food is often considered unhealthy because much of it is high in both fat and calories, but are the two related? Here are the fat and calorie contents for several brands of burgers. Here's the fat in grams. Here's the calories. So first thing we want to do is create a scatter plot for the data on your calculator. Okay, so there are calculator instructions on your unit packet, so I'm going to go through that now. So first we need to put the data into our calculator. So how do we do that? Well, we want to go to, turn our calculator on, go to Stat. Right now it's on Edit. It's on the Edit menu, and the first choice there is Edit. We want to do that, so we hit Enter. Now, your calculator may have information filled in here. It may not. We're going to change that information anyway. So we're going to use List 1 and List 2. That's what L1 and L2 stand for. So I'm going to go to, since my cursor is here, I'm going to go over to the top of List 1. And since I have data in here, I'm going to hit Clear. Now notice that nothing happened yet. But as soon as I move off of List 1, now that value, or those values, are clear. I'm going to do the same thing with List 2. I'm going to go to the top so that the cursor is on List 2, or List 2 is highlighted. I'm going to hit Clear, and then as soon as I arrow down back into List 2, that is empty now as well. Okay, so we're going to go over to List 1, and we are going to put our data in. So our first data entry for List 1 is going to be 19. Hit Enter, then 31, then 34. And now, as I'm going through this, I want to point out the order in which you put these in does not matter as long as they match up with their corresponding List 2 value. So as long as the correct calorie count matches up with the fat count, it doesn't matter if you put them in the order of how they're given. I would recommend that you do, just so you don't mess yourself up though. Then we'll go 35, 39, 39, and 43. Now, if you needed to, there are other statistical tools on the calculator you can use to help you find out information about this data. Again, we're not going to do that right now. In another statistics class, you might. Now I'm going to go over to List 2 and put in all of the calorie counts, make sure they match up with the fat counts for that particular value, or for that particular burger. So I start with 410, 580, 590, 570, 640, 680, and 660. Now, it's obviously very important that you put the data in correctly, because if you don't, it's going to mess up everything you do from here. Okay, so we're still working on creating a scatter plot. So once I put the data in, I'm going to quit out of the list menu. So I'm going to do second mode, which is quit. And now to create a scatter plot. Notice how if you look at your Y equals button, above that you see stat plot. So I'm going to do second Y equals. And now I have different plots. Well, I'm going to go to plot 1. I want to turn it on. And then this choice here, where it's just a bunch of dots, that is a scatter plot. There are other things you can do, again, with statistics, but right now we're just going to do scatter plots. So we want that first choice highlighted, and we want to make sure that the X list is list 1 and the Y list is list 2. If those are not correct, then we can go down there and we can enter those in. You'll see above the 1 button on your calculator, you see an L1. So if I needed to change this, I would second, and then 1 would put in list 1. and then L2 is above the 2 button. So that's how I could change those if I needed to. Okay, so now we turn the plot on, and it's plotting list 1 versus list 2. So how do we see that? Well, if I go to graph right away, I don't see anything. So maybe I think I did something wrong, but instead I'm going to go to zoom, and then if you scroll down, the 9th choice under zoom is zoom stat. So I went a little too far there, zoom stat. So if I hit zoom stat, it's going to fit the window to my data. Okay, so that is my scatter plot. Looks lovely, right? Okay, so create a scatter plot for the data on your calculator. We did that. Moving on. Describe how the variables are related. So this is something I want you to do. So I want you to take a minute and look at this information. Keep in mind that the X list is what? Well, the X variables were our fat, and the Y list is calories. So just use words and come up with ways in which you can describe these variables being related. So I want you to pause the video and write down a few ways in which you think that they're related. Unpause when you're done. Okay, so you don't have to have exactly what I have written down, but hopefully you recognize that as fat content increases, the amount of calories appears to increase. You could also, maybe you said something along the lines of it looks perhaps possibly linear, or a direct relationship. That's a pretty mathematical term, so if you didn't say that, that's fine. But you do want to be able to put in the context of the problem, which is fat and calories, their relationship. And that is, as one increases, the other also appears to be increasing. Whether you recognize that they appear to be increasing at a linear rate or not, or whether they are actually increasing at a linear rate or not, is not as big of a deal. Again, that's something you would figure out more in a formal statistics class. But for here, you want to be able to at least recognize, in the context of the problem, as fat increases, calories appears to increase as well. Notice that I use the word appears, and that's because usually in statistics we never want to say definitive statements. We always want to leave ourselves a little bit of wiggle room, because it's just a statement based on some data. It's not a proven fact. Okay, next thing, use your calculator to create linear regression for the data. What is your equation? Okay, so we're going to go back to our calculator. The data is already in there. How do we do a linear regression? These directions are also on your packet. We're going to go to Stat, and now we're going to go over to Calc. So Calc, and we are going to do linreg. See, that is the 4th choice down. There is also a linreg that is the 8th choice down. We're going to use the 4th one. Does it really make a difference? No, as long as you are conscious of which one you use. I would recommend the 4th one, though, because it's going to make more sense to you in terms of the equation, or how the equation is written. So I'm going to hit Enter. Now, depending on how old or new your calculator is, you might get a different menu than I have here. That's okay. The basics are the same. So what do I want to do a linear regression of? I want to do a linear regression of list 1 versus list 2, and I want to put it into Y1 on my calculator. So I'm going to do second list 1, comma, second list 2, comma, and then to find Y1, so these first two things are which lists am I doing a regression about, and then where am I going to put it? I'm going to do vars. I'm going to go over to yvars. I want function, and I want Y1. Okay, so I still don't have the regression yet. Now to get the regression, I hit Enter. And it gives me Y equals AX plus B, where A is 11.05551212 and B is 210.9538702. For right now, we can ignore the R squared and the R. We might talk about those later in this class. We're not going to talk about them right now. If they did not show up in your calculator, that's okay as well, because again, for right now, that's not important. Notice what A is. A, this is in our form of, normally we're used to seeing an equation, Y equals mx plus b. Well, here it gave it to us as Y equals ax plus b. So A is our slope, and B is our y-intercept. So now we want to actually write the equation of our line. So go ahead and do that. Alright, so I wrote the equation down with the variable x and y. You could put in the actual variables that, remember, you always want to keep in mind, well, what does y represent? Y represents calories, x represents fat. So it's very important that you keep those in mind as well. Okay, so now we want to graph the equation on our calculator. Well, it actually already did that for us, because when we chose to put the equation into y1 on the regression, it put it in there. And so now if I look at the graph, it has that line already graphed in there. Okay, great. So now the question is, do you feel that this equation is an accurate model for your data? So this is your opinion. Do you think this equation, so look at your graph, do you think that fits the data well? So I want you to think about that, write an answer, and give a brief explanation. Pause the video, unpause when you're ready to discuss. So I said yes, the line appears to fit the data well. Remember earlier on in my explanation, or for the relationship between the variables, I said it appears to be linear. So had I not said that earlier, I would say something like that here. You might say something along the lines of it appears to come close to or hit most of the data points. Again, though, not every relationship is going to be linear, so you want to actually think about this and give the answer, the best answer you think you have. Okay. Next thing, interpret the slope of the linear model in the context of the data. So what was our slope? Well, our slope was this 11.0555. So I want you to take a second and think about what does that mean in the context of the data. So pause the video, write that down, unpause when you're ready to check. Okay, so I said for every 1 gram increase in fat, the calories are predicted to increase 11.0555. Notice I used the word predicted. That's because, again, this is a model. It is not necessarily what is going to happen. And this is how you should always interpret the slope in the context of the model when we're doing this sort of statistical plotting. That it's always going to be for every 1 unit increase in the x value, the y values are going to increase or are predicted to increase or decrease whatever amount the slope is. Okay, I want you to now do the same thing with the y-intercept, or the constant term of the model. So interpret it in the context of the problem, pause the video, unpause when you're ready to look at your answer, or compare your answer. Okay, so what does the y-intercept mean? Well, in this case, I would say it's a burger with 0 grams of fat is predicted to have 210.95387 calories. Again, key thing is to use the word predicted because we're using a model. Alright, last part, use your equation to predict how many calories there would be in a burger with 28 grams of fat. Does this value make sense? And then use your equation to predict how many calories there would be in a burger with 50 grams of fat. Does this value make sense? I want you to pause the video and do both of these. The first one is called interpolation. The second one is called extrapolation. It's called interpolation because 28 grams is within the domain of data, or within the domain of data, or the interval of data in which we were given for fat. 50 is outside of that. That's why this is called extrapolation. So pause the video, answer both of them, and then unpause when you want to discuss. And by discuss, as always, I mean just listen to me talk in my lovely, calming, soothing voice. Okay, for the first one, if we plug in 28 for x into our equation, we get 520.508 calories. Does this make sense? Yeah, it seems to be a reasonable number. Since we said earlier on that we think our model is a good fit, then, yes, the line appears to fit the data well, then, yeah, that should make sense because 28 is within the interval of our data. For the next one, we plug in 50 and we get 763.729 calories. Does this value make sense? Well, in this case, yes, it probably does. 50 is not that far outside of our data. Our model does appear to be good, but we do need to be careful with this. So whenever you're dealing with data and you are trying to use a model and you are doing extrapolation, so you are plugging in values outside of your interval of data, you have to be very careful in what you do with that answer in determining does it really make sense, or you really want to make sure you think about does it make sense. Okay, that's Scatterplots and regression.